G'day everyone. I'm just going to go through a proof today just to demonstrate sort of different types of things you might have to do. So let's have a look at this question. This is actually like a fairly good question, what you might sort of see in an exam. So let's have a look at this. So given 3 points there, show that ABC forms a right angled triangle at B and hence determine the area of the triangle. Okay, so I really strongly encourage you to draw diagrams when you're starting proofs like this. It really sort of helps you sort of be able to figure what's going on. And so it's saying that, proving that ABC forms a right angled triangle at B. So at B, we're trying to show that this angle here is 90 degrees. And so let's draw it similarly to that so as we can get our head sort of thinking about it in the right sort of way. And then hence determine the area of triangle. So first things first, we want to show that this thing is right angled. How do you show that something is 90 degrees? We want to show that the dot product. So I want to show that AB is perpendicular to BC. That's a little perpendicular sign there, it's not a plus. I want to show that AB is perpendicular to BC. In other words, I want to show that AB dot BC is equal to 0. The dot product of those two should be equal to 0. Okay, so let's go and do that. So let's find AB. Okay, so vector AB. So remember AB is equal to OB take away OA when we're sort of doing our vectors. And so I'm going to sort of skip a couple of steps here, but OB take away OA. So it's going to be this take away this. Okay, so firstly we've got 4 take away 8, so that's negative 4i. And then we've got 5 take away 3, so that's plus 2. Sorry, I did I, but it should be j. And then we've got negative 2 take away negative 1, so that's negative 2 plus 1, so that's minus 1. Okay, so there's my AB. Now we need BC. Just to save, no, I'll do it down here, that's okay. I'll do BC is equal to, so remember BC is equal to OC take away OB. Okay, so C take away B. All right, so 7 take away 4 is 3i. 9 take away 5 is 4j. And negative 6 take away negative 2, so that's negative 6 plus 2 will be negative 4k. Okay, make sure I put all that tildes in there. So there we've got AB and I've got BC. All we need to do to prove that they're perpendicular is to find the dot product. So let's do that. So therefore AB dot BC is equal to, so negative 4 times 3 is negative 12. 2 times 4 is 8. And negative 1 times negative 4 is plus 4. Negative 12 plus 8 is negative 4. Negative 4 plus 4 is equal to 0. Oops, that's a bad 0. Sorry, it looks more like a messy 6. Is equal to 0. Therefore, AB is perpendicular to BC. And that's what we're trying to show. So that's the end of the proof. So I've proved that those two, that's right angled triangle. Okay. So now that we know it's a right angled triangle, the second part of the problem, I'll switch colors. Second part of the problem is to find the area of the triangle. So this is a good exam question because it does a bunch of things. It sort of covers a lot of different ground. So the area of the triangle is going to be half base times height. In other words, it's going to be half magnitude of BC, times the magnitude of AB. Sorry, my writing's a bit bad today. AB. So that's what we're trying to calculate here. Okay, so here we go. So half. Let's have a look at BC. BC, where was it? Up here, 3i plus 4j plus 4k. So that's going to be 9 plus 16 plus 16. That's all in the square root there. And magnitude of AB is going to be the square root of 16 plus 4 plus 1. And then we just need to sort of calculate this. And what have we got? That's going to be the square root of 32 plus 9, which is the square root of 41. Ugh, pretty yucky numbers. And the square root of 21. Disgusting numbers as well. What's 41 times 21? I'm just going to quickly consult my calculator rather than sort of doing it on screen, but 41 times 21, so like 40 times 21. Just give me a second, just get my calculator. Save a bit of time. 41 times 21. That's 861. So it's root 861 over 2. And that will be, we haven't been given any units in the question. No. And so we've got an area, and that's units squared. So that will be the answer for that one. Hope that makes sense. See you in the next video.